All right. So 4.1 talks about inequality. So you see there at the very top of page 144 that an inequality is a statement comparing two quantities that are not equal. The key is, when working this, is that your equalities are in the right direction. So we know they're not equal. So they can either have the greater than and a greater than or equal to. They can have a less than symbol or a less than and equal to. And then we have the sign that actually means not equal. And when you're solving for a non-equality, that means that you solve for that one variable that makes them equal. And so a possible answer is every other number that exists infinitely, except for that one number. We'll talk about that more. Okay. So an inequality is a mathematical sentence stating that two quantities are not always equal. And we've gone through those. Some important things to remember is things like at least or at most. So when I say that A is at least 8, that means that it can be equal to 8, but it must also be greater than, right? Because the smallest number it could ever possibly be equal to is 8. So and then it includes every other number that could be bigger than that one. And when I say that it is at most, so if A is, so this is your at least. These would be good to have if I've already done this with my pre-algebra class to a smaller extent. If the quiz is anything like theirs is, make sure that you know that at least means greater than or equal to, and at most means less than or equal to. Because that gets really confusing because you see most and you think more than, and you see least and you think a smaller number. So people tend to confuse the verbal terms for these symbols. Okay, so they're sort of close to the bottom of page 144. They introduce the trichotomy property, which says that if A and B represent two real numbers, then A equals B, A is greater than B, or A is less than B. So what are real numbers? All of them. Yes. That means your rational or irrational, your integers, your whole numbers, or your natural numbers. That's, I think, that paper that you just threw away, Gabe, where it had the Venn diagram, a circle inside of a circle inside of a circle. And that's fine. We did that the very first chapter. So we understand that if it says it's a real number, that means it's every possible mathematical number known to man. All right. So placing a slash through the symbols, greater than, less than, greater than, equal to, and less than equal to, results in their negation. So it just means that it is not greater than or not less than. So you put a slash, then it just makes it a negative. All right, so for example 1, it says state an inequality equivalent to X is not less than, let's put 8, Y. So this is example 1. X is not less than or equal to Y. So your answer to that is X is greater than Y. Because what you're saying here is you're saying first, X can't be less than Y. But you're also saying what? X can't be what? Can't be equal to Y. Right here. That's what this is telling us. So when you're negating it, that means that you're saying it doesn't include the equals and it doesn't include the less than. All right. So example 2 is big. Let's just work through this. So example 2A. So it says for in each inequality, determine which of the following are solutions. And they give you the set 2, 3, and 4. So A is A plus 3 must be greater than 6. All right. So how do they do this? So what they do, okay, so they just plug in the values for these. I guess I'll do that. I mean, I think we're probably already at the next step. Let me just see what they do here.
Wrong.
Yes.
I realized what I did wrong on this one on my test. I mixed it up, so I meant to put 10 gallons of number 24.
When you don't show your work, I'm not able to determine that. Okay, so A plus 3 must be greater than 6. So if you plug in the values they give you, so just plug in the value of 2 plus 3 greater than 6, and I would do 3 plus 3 greater than 6, and 4 plus 3 greater than 6. So when we do that, that becomes, what's 2 plus 3? Right, 5. Is 5 greater than 6? No, that's why it's false. And then 3 plus 3, 6, greater than 6. Is 6 greater than 6? Right. If it was greater than or equal to, we'd be in business, but it's not. So this is also false. And then 4 plus 3, and 7 greater than 6. Yes, we're good. Okay. All right, so what that means though, so if you look at, that, once you have determined which one is true, so if 4 plus 3 is greater than 6, that means that if they gave you a set that maybe said this, maybe your set said, oh, that's wonky, 3, 4, 12, and 19. And you determined here that 3 is false because 6 is not greater than 6, it's equal to. And then you determined that 4 is true. And you know that as long as the rest of your numbers are positive numbers larger than 4, they will all also be true. Right? You got that? Playing on your watch. Oh, gotcha. Tap, 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 tap. Okay, that's fine. All right, so the next section of this that we look at is where we actually graph these on a number line. So let me look at what they're saying here. The numbers -3, 0, and 4.5 are all solutions to 5 is greater than X. I'm right there under example 2 on the paragraph in the middle of page 145. Usually, it is not possible to list all the solutions to an inequality because they are infinite. So what we do when we try to represent the solutions to an inequality, we graph them on a number line. So the one thing I want you guys to remember when you think back on previous arithmetic classes, when we number on a number line, how would we represent X is greater than 3? Right, we'd start at 3, 0, 1, 2, 3, 4, 5. So we'd start at 3 and then we would increase our number line in the positive direction, so to the right. But would 3 be an open circle or would it be a closed circle? Y'all remember this at all? You don't remember? What is it? A little. So do you think with x is greater than 3, when we put our dot, we represent 3 on the graph, would we use an open circle or a closed circle? Why? That's the part you don't remember? Okay. All right. I'm sure they say it in here, probably there in example 3. An open circle means that's when you use greater than or less than, but it means that the number is not included in possible solutions. If you have greater than or equal to, less than or equal to, then use a closed circle because it means the number is included. So in the case of 3 is greater, or x is greater than 3, would 3 be a possible solution for x? Is 3 greater than 3? No, it's equal to. Therefore, when you put this on a number line, you would have an open circle, and then you would draw your line in the positive direction, so to the right, because 3 is not included. So if I had x is less than or equal to 3, then you would have your number line. Well, I put so many on there, but whatever. 0, -1, -2. So is the 3 closed or open? If it's x is less than or equal to 3. Is 3 included as a possible solution? Yes, so we would use closed. And then draw our line to the left to smaller values, because 3 is included in your solution. So that's what they're showing us here for example 3. Because in this one, it says x is greater than or equal to -3. So you have a closed circle at -3, excuse me. And then you see where they've drawn the line to the right for all the numbers larger than -3. All right, so let's look at example 4. That's at the very top of page 146. So when you have an inequality symbol that excludes only equal to, so you have x does not equal to, then when you draw that on a number line, just give myself some room, x does not equal to, so you draw your number line. All right, so where should we start? Where should we put our circle? At the number 2. And is it open or closed? Open. Because 2 is not included. But everything else is. Everything smaller than 2 and everything greater than 2 is not equal to 2. So you want to make sure that you draw your arrow from that point in both directions, which you can see right there in example 4. This is all coming back to you guys a little bit. All right, let's do some exercises. And I think that will probably help. So these are going to be, you know what, let's just go and work on the homework. I will use the additional problems to reintroduce this first thing Monday morning, so we can get our brains back on track. Let me see what I left for Ava. We'll make sure we work on the same thing. All right, so yeah, 1 through 31 odd. Okay, so this is not homework for the weekend, but this is the homework assignment for this section. But for 4.1, let's work on, we'll start with 1 through 30. What did I just say? Totally lost it. 1 through 31. Odd. All right. So we'll go through these. So for 1 through 7, we need to match each phrase with its equivalent inequality symbol. So number 1, is at most represents which symbol? I have to write these out when I work with that at most and at least. If I said that I'm just going to use A and 3. So if A is at most 3, what does that mean? Does it mean A can be 3? Because it's, yeah, it can be 3, but that's the most it can ever be. So we know it can be equal, but is the top one then greater than or less than? Well, like, you know, we usually have like this or this. It's like above the equal part. Right. So 3 is the largest it can possibly be. So that's the greater than side. And so that means that A must be less than or equal to 3. So when we say at most, that means which symbol here? A, B, C, D, or E? D. Yes. So number 1 is D, which is your less than or equal to. All right, game number 3. Okay, is not less than. So if A is less than 3, then how would we say A? Hold on. Yeah. So A is not less than 3. Is that what it's telling us?
Mhm.
So it's a negating less than. So what symbol is it?
Wow, that one. Oh, with the line.
Greater than or equal to?
Equal to. No, greater than.
So how would we say this without having that negation in the middle? What is the, so if I say it's not less than, then I'm saying,
Three higher than A. What? Okay, I think I know what you mean.
this is what we talked about in that very first example 1. So if I say A is not less than, then it is equal to, and if it's not less than,
Equal to.
it's equal to and greater than. You didn't say the greater than. So if I say A is not less than, then that means I'm saying A is equal to or greater than. So it is very confusing, especially when you try to do it verbally. Once you memorize them, it makes sense. But inequalities can get really confusing, especially when you're turning it from a word phrase to a symbol. So that is C, greater than or equal to. Okay, Abigail, number 5. 5 says, is not as much as. So let's look at our A and our 3 again. So if A is not as much as 3, then what must it be? Less than. Can it be equal to? If it can't be as much as 3, that means it can't be 3. Right. So it must only be less than. Yeah, if it said A cannot be more than 3, then it can be 3. It just can't be 3.001. Right. Okay. So which symbol is that? That is B. Am I right? Okay. So that's B. less than. All right, Eden, number 7. I feel like this is the hardest part. Going from word phrases to symbols is harder than actually doing the math piece. So don't beat yourself up too much. So if it says exceeds, what was that? What would that mean? So if I say A exceeds 3, which symbol would I use? Yep, greater than or more than, same thing. So that's what A more than. Okay. All right, that's actually a really good exercise. Those are good practice. Okay, so let's move on to the actual, let's work with the symbols and the numbers. All right, so back to the guys table. Number 9. So for number 9 and number 11, we need to write an inequality equivalent to the given inequality. So it looks like in all of these, they're giving us negated inequalities. So we need to actually write that without the negative. So how would we say X is not greater than -4? X is less than -4. Can it equal -4? It can. So if I say X cannot be greater than -4, that means it can include -4 and smaller, but it can't be more than, it can't be -4.0, well, actually that's -3.99999. It can't be more than. So in this case, and remember that too, if you're going from a negation to an actual inequality statement, if your negation includes the equal to, your inequality will not, and then vice versa. So that should be pretty easy to memorize. All right, Gabe, number 11. So if I have Z is not greater than or equal to 21, how could I say that without having that negation line in it? So if Z is not greater than or equal to 21, then it must be what? Less than 21. There you go. Exactly. And because X cannot be equal to 21, then we do not use the equal to portion of this symbol. It's just less than. All right, I think we got it. We have what? We have about 10 more minutes. All right, so number 13, we need to determine whether each number is a solution of the inequality. So Abigail, number 13 says 2m must be less than 4. So A is -2. So I'm going to plug that in for the value for M. I put the wrong number too. I'm already doing the math in my head. What's 2 times -2? What do you think? What's a positive times a negative? Remember, a negative times a negative makes a positive. So positive times a negative, your answer must be negative. Yep. Is -4 less than 4? Definitely. A negative will always be less than a positive. So for number A, it is true. All right, so B gives us the number 2. So 2 times 2 is less than 4. So what's 2 times 2? Is 4 less than 4? No, because it can only be equal to. So that one is false. And then the last one here is 4. So 2 times 4 is less than 4. And what's 2 times 4? Right. Is 8 less than 4? So if we have -4 or -2, 2, 4, 6, 8, you can see with this pattern that anything larger than 2 is going to give you a false answer, because that means you're multiplying a positive times a positive. So you're going to keep getting larger and larger positive answers, which are going to continue to be more and more false. Crazy. All right. Eden number 15 is R. You get the fun one. R squared minus 2 is not greater than -1. All right, so first I would get rid of that negation. How do we say R squared minus 2 is not greater than -1? What do I need to change that not greater than to? That means it must be or, yeah. So I would immediately change that to the opposite. So just flip it if you see a negation. Flip it, you'll be fine. And make sure if it has an equals to, that you don't include that. And if it doesn't have one, that you do include it. Okay, so yes, so R squared minus 2 must be less than or equal to -1. And then they give us A is 0, B is -1. I'm trying to find my place here. And C is 2, right? Yeah. All right, so if we plug 0 in for the value of R, what's 0 times 0? It's just 0. So just ignore that. That's going to be 0. And I can't write things correctly at all today. So is -2 less than -1? Yes. So A is true. This is yes. Or it's always put it's true. All right. So B is -1. So if we put a -1 to -2 is, oh, sorry, I forgot the equals to. Less than or equal to -1. What's -1 times -1? Yeah, it's what we get rid of the negative. 1 minus 2. Why do I keep doing that, y'all? Oh, 1 minus 2. What's 1 minus 2? So that gives us -1. And is -1 less than or equal to -1? It's equal to, so it works. So this again is yes or true. All right, so last one, we have 2 squared minus 2 less than or equal to -1. And what's 2 squared? 4 minus 2. And what's 4 minus 2? Is 2 less than or equal to -1? No, it's much bigger. So this is a no or a false. All right. Easy enough? We all feel good about this? So easy, it's putting you to sleep, right? That's okay. We'll reintroduce it on Monday. So everything your brains forget over the weekend, we will do again. Let's see, 217. All right, so let's work on these number lines on number 17 and number 19. So let's see, number 17 and number 19. Write an inequality to describe each of the following graphs. Then write an equivalent negated inequality. Ugh, okay, fine. All right, so on the first number line for number 17, they've given us an open circle at 3, and then our arrow points to the right, so it increases in value. So x and 3, what's our relationship there? Is it greater than, less than? Yes, x is greater than 3. Is it equal to 3? No, right, because we have that open circle. So what's the negated inequality we can get for this? Right. X is not less than or equal to 3. Remember, if the equal to part is not included in your true inequality, then it must be included in your negated inequality. All right, number 19. So for number 19 on the number line, we have a closed circle at 18, and then the arrow moves right. So Gabe, how would we write that? X is what? First off, what number are we putting to the left of our inequality here?
Sorry, what?
Number 19.
Oh, 18.
18. And is x less than, equal to, greater than, equal to, less than, or greater than? So it's greater than. Does it include 18? Or greater than or equal to? All right, so what's the negated inequality to this? If x is greater than or equal to 18, then it is not less than 18. All right, let's do 21 and then we'll call it done. I want to just do one graph so you've got it as an example. And I have some graph paper if anybody wants it. Okay, so number 21 says x is less than, actually, we can do 21 and 23. That way everybody gets an even number. Like, it's okay, really. So x is less than 4. So where do I put the dot on my number line? Abigail, I'm just gonna put 0, 1, 2, 5. At the 4. Like we're starting at 4, right? So whatever we have x, our variable inequality number, that number on the other side, that's where we start our arrow. So in this case, is it open circle, open dot, or closed dot? It is open dot. Remember what those mean?
I remember stuff about open dots.
So remember, an open dot means that your x is not equal to 4, but that's where we start. And so in this case, x is less than 4. So it does not equal 4, which means we leave that open. So that just tells us where to start our line, but it means we don't include that number. And now, in which direction does our arrow go? Left, smaller, or right, bigger? Yeah, we go left. And so that number line shows us every possible solution to x is less than 4. All right, Eden, last one, 23. So 23 says x does not equal 5. Put 5 right here, 4, 2, 6, 7, 8. All right, so where do we start our line? At the 5. And is it open or closed dot? Does it include 5? So it must be open. Now, which direction do we go in if we're saying that if x does not equal 5, which direction does our arrow go in? Absolutely. This is the case where it must go in both. So we go, every number greater than 5 is not 5, and every number less than 5 is not 5. Okay. All right, so that's it. We'll leave that off. We'll finish that on Monday along with some additional problems to get our brains back in the right place and introduce the different properties of inequality. So you guys are done. Have a wonderful weekend.